Hi all, my name is Gulshan Banu, working as an assistant professor at AIDS department, SNS College of Engineering. So we are in the series of unit 3 called game theory, and in the previous video we saw what is game theory and what is the process and how it is being involved and what is the different kinds of methodologies involved in it. So now in this next topic we are going to see like what is optimal decision in games. So, as the name says, optimal decision is something in which you will take the techniques and the methods that is involved for doing a process which involves a very optimal strategy. So, whichever game you are taking, be there it's a chess or a pseudocode or whatever it is, whatever you are doing, you have to play a game in a very efficient manner and in an optimal way, right? So, optimal decision in games is something which is related to a topic. It is a fundamental challenge in the field of artificial intelligence. There are various techniques and approaches that have been developed to enable the AI agent to make the optimal decisions in game. Okay, now we will see what is the different concepts that is involved in the optimal decisions. One of the major important topic of this optimal decision in games is the min-max algorithm. Now the min-max is something that is defined with the minimum and maximum value, as I have explained you in the previous video. Now there are different concepts that is being involved in this min-max algorithm. That is nothing but now you will be having different methodologies. That is, you have to start with the maximum. The starting value will always be a maximum value. Now what is called as an expanding nodes? Expanding nodes is something which you will expand the different kinds of nodes that is involved in it into a certain depth. Okay, now what is this? Evaluating the function. Okay, now at each leaf node you will be doing different kinds of evaluation process. That is, in every process you will be having a root node and a leaf node, right? So the different evaluation process that you are doing in the leaf node is called as an evaluation function. Backing up the values is like say for example you have done some error and you have to do the process in an efficient manner. You will be backing up the different values. Min max moves is something that you will be doing with the minimum values and the maximum values. You have to choose accordingly, either it's a minimum value or maximum value, and what is the different process that is involved in it. Now what is the property of this min max algorithm? You have different properties, that is complete solution, optimal strategy, time complexity, and then the space complexity. Complete solution is something that you will be deriving the complete solution of the process. Optimal strategy is the minimum strategy that is being involved in the process. Time complexity is the time that is being involved, and the space complexity is the space that is being involved in the different gaming process. Now what is called as this min-max algorithm? Now min-max is something that is based on the minimum value and the maximum value. Obviously min is something which has the lowest value and max is something which has the highest value. Now this min-max algorithm follows the backtracking algorithm. In this you will be involving two players based on it. Now in this min-max algorithm you will be taking out two different processes. That is, in the root node you are having two processes, that is H, I, J, K, L, M, N, O. The last node will be denoted as the terminal node. The next node will be denoted as the maximum node. Next node, the above process will be denoted as the minimum node, and the above process will be denoted as the maximum node. So as I have already explained you, the first node will always be the maximum node and the last node will be the terminal node. Okay. Now when you are taking the terminal node, you will be taking H and I values. Okay. Now the H value is 1 and the I value is 2. The node of D will be your maximum value. That is, when you take 1 and 2, which is the maximum value? It is 2, right? So the value of D is 2. Now when you take J and K value, you have to find out the value of E. Now when you are taking J and K, the values are 5 and 7, right? So in this the maximum value is 7. Now in this L and M you have 0 and 1. When you take the node value of F, the maximum value is 1. So you will be taking the F value as 1. Now in N and O, the maximum value is 6. You will be denoting the G value as 6. Now when you are taking D and E, the node values are 2 and 7, right? In this you have to mention the minimum value. Now you will be denoting the B value as 2. Now in F and G you will be denoting the minimum value of C, right? So value of F is 1, value of G is 6. Now the minimum value, when we compare F and G, the value of C will be 1. When you take two nodes of B and C, the values are 2 and 1 as of now. In this, the maximum value is 2, and then you will be uploading the maximum value in A. Okay. Now, when you are uploading with this process, you will be having different kinds of process, like how you should involve the process and what is the methodologies and all. Okay. Now you are adding the min-max value, and then you are displaying it in an efficient way. In this optimal decision in games, in min-max algorithm, you will be following a value of alpha and beta. That is, the maximum value is minus infinity and minimum value is infinity. That is, the alpha equal to minus infinity and beta equal to infinity. When you compare these two values of 1 and 2, first value is the maximum value, right? So you have to update the maximum value of a node of 2. Now the node value of is 2, but when you are calculating with alpha and beta, you have to update the alpha over here. You will be updating the alpha and you will be defining the values of maximum and minimum values. Okay, this we will see in the alpha and beta pruning methodology. Okay, so I just told you that the minimum value is infinity and the maximum value is minus infinity. So you, in this min-max algorithm process, you will be defining the minimum and maximum values. Okay, now we will see what is tic-tac-toe method. In this tic-tac-toe example, you will be having different methodologies. That is, you will be having two players, you will be having the initial move, you will be having the alternating turn, you will be having the utility value and the max strategy. Okay, now in this tic-tac-toe, we are taking the first node as x and o. Okay, the first node will be in the first row, you will be having 0, 0, x empty space o, and the last column will be only x. So in the first step, what you can do is you have to place the x value. Okay, now when you are placing the x value, there are three possibilities, that is in the three different possibilities. After that, you will be stating like where you can put the o and where you can put the x. Okay, in that process you will be having different winning and losing strategy. In the first methodology, they have placed the x in the different directions. Next, what they have done is they have given the o, they have placed the o over here. So minimum move is like involving with the x decisions, and o will be placed in the other minimum position. That is, first in the maximum position you will be placing the x value, and in the minimum position you will be placing the o value. In each and every term, you have to see like who is winning first. Say for example, if you place x in one position, the possibility of winning x and the possibility of winning o. Okay, so in this you will be calculating the heuristic value of each process. So in the first process, the heuristic value will be either 1 or 0, or it will be either draw. Okay, likewise you have to follow each and every process that is involved in it. Okay, so on the whole you have to first involve the x, then involve o, then involve x. Like that you have to do the process simultaneously until you reach the goal state. In this process, either x can win or o can win, or you can attain the draw position. Okay, now in optimal decision makings in multiplayer games, you will be involved with the different values like 1, 2 and 6, 4, 2 and 3, and you will be denoting it with v of a, v of b, v of c. Okay, likewise in the second process you will be taking v of a, v of b and v of c, and you will be denoting and you will be taking the minimum values first. Next, in the next level of node, you will be taking the maximum value, and in the next process you will be taking the maximum value, and this is how you will be defining it with the optimal decision in games. So as of now, I think that you might have got clear like what is optimal decision in games and what is the process that is involved in it. In the next video, we will see the other steps and the other process that is involved in it. Thank you.